All right, here we go. Welcome to lesson 4.2 video notes. We're in chapter 4 here on reflections. So we're continuing with different transformations. Previous lesson 4.1 looked at translations. This is just the next one up, 4.2 reflections. So let's jump in, let's get it going. So just, in class, what we did, we'll define, just like we did with translation, what is a reflection. It's a type of transformation. Okay, so you pause here, you write down reflection as your vocab word. What is it? A transformation that uses a line like a mirror to reflect an image. That's not maybe the best definition, like you're using the word reflect to define the word reflection, but I feel like it's such a common language. We're flipping is maybe another way to say it, that uses a mirror to flip an image. Okay. And then the other just vocab that goes with this, that, kind of a sub vocab word, is the line of reflection. So what line are we going to be flipping over, basically? We call that the line of reflection. So there's a couple different ways we're going to do reflections here. Let's start with rules. And then, like I said, I've got it all set up with some examples. There's some different ones we'll go through here. It's not super long. I'm trying to decide here in the spot. I think actually, let's go here. Let's add the rules, and then we'll come back and see if we need to clean anything up, okay? So basically what we're going to do in this class, we're going to use these rules like we've seen, kind of close to translation rules, worded a little bit differently, but we're going to reflect over 4 special lines, okay? The x-axis, the y-axis, the line y equals x, and the line y equals negative x. Okay, we'll get to this here in a second. If you're not 100% sure, we'll kind of just pause that right there. The line, hopefully you know what the x-axis and y-axis is, but if you need to, for these bottom two, what does the line y equals x look like? If this is my x-axis and this is my y-axis, the line y equals x is a 45-degree line. Basically, the coordinates on this line would be 1, 1, 2, 2, 3, 3, 4, 4. Literally, the y equals the x. So that's the line y equals x. That's what that looks like. We'll reflect over this line. And then wherever we can fit it, in class, we'll leave a little bit more space as we're doing these one at a time. But for this, I guess I'll just, the bottom one up here. What does the line y equals negative x look like? It's going to be super similar. This is my x-axis. This is my y-axis. You could probably figure this out. This is the line y equals negative x, a 45-degree line passing through the origin, just with a negative slope. So down 1 over 1 from the origin. So negative 1, negative 1, 2, negative 2, 3, negative 3 would all be points along that line. So that's the line y equals negative x. You might want to sketch those just so you have an idea of what those lines look like. We mentioned it already. This is the x-axis. The y-axis will reflect over those. Okay. So those are kind of the 4 what we would call special lines that we'll use these rules for. I guess I didn't even mention the rules yet. We have rules that you'll get. You don't have to memorize these rules for right now. Obviously, you're putting them in your notebook. But the interpretation here is this, that if you have a point AB and you want to reflect it over the x-axis, its image, right? This would be the pre-image. This is the image point is going to have the coordinates A opposite of B, I think is the better way to say that, instead of negative B. Because if B was originally negative, it'll be the opposite of it over here, which would be positive. Okay, so that's just an example. That's how we would interpret these rules. That's how you'll get them presented to you. If you wanted to reflect over, we'll just talk through one more. If you want to reflect over the line y equals x, what happens? The point AB becomes the point BA. So that's an example of we're literally flip-flopping our x and y coordinate from the original point. Yeah, so we'll do a couple of them. I don't think we have time to do, or we don't need to do all of them, but you'll get these rules. You'll have to be able to take it as the way it's presented and know how to, apply it to a graphing situation, okay? I think the last thing, like note-wise, if you're looking ahead, most of this, the only other note section is right here. If we will do some reflections. That's actually the first 2 examples over other lines some just kind of random vertical or horizontal lines. When we reflect over, how do we do this? It's basically, we're just going to count how far we are away from the line with the pre-image, and just know that my image is going to end up that same amount of units on the other side of the line. Okay, so let's jot that down here for, it's still in the section. It's not necessarily it's not a specific rule. It's kind of just how we're going to do a reflection over any other line besides these four. Okay, let's start actually with this one. I think I've got two here, and then we'll do one of the rule. I don't remember which of the four it is. So let's do it. Let's do some examples here. How are we going to do a reflection? So kind of split them up here. Darn, I wish I could see. Maybe can I bring the text box up over here? Whoa. Let's try it again. Just so we can kind of see what's going on without having to scroll everything. There we go. All right, let's take a look. It tells us here, example one, the vertices of triangle ABC are ... Okay, graph the pre-image. Let's get that banged out. We can get that done. Where's the point? A1, 2 would be right here. B is the point 1, 2, 3, 0. And C is the point 1, 2, 3, 4, 5, 1, 2, 3. Okay, so we'll graph. This is my pre-image. So I'm going to label my points as A, B, and C. Okay, so we've taken care of that. We've graphed the pre-image, and now it says graph the image after the reflection of ABC as described. It says, so this is one kind of subtle thing to pay attention to. It says in the line N, which has the equation x equals 2. So that's kind of technical. That can be confusing if you're just looking at it like that. Like, what does that mean? In the line N, x equals 2. The interpretation there is that's just basically saying, let's take this triangle and all these points and reflect them over the line N, which has the equation x equals 2. So now this goes back to actually last chapter a little bit, where we talked about equations of vertical and horizontal lines. What does the line x equals 2 look like? This is something we're going to have to know and be able to do. It is a vertical line, and all the x coordinates on that line are 2. So like 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Okay, so this is a vertical line where all the x coordinates are equal to 2. So the first thing we do when we do one of these reflections is, if it's not one of my special lines or it's not an x or y axis, I want to put that line of reflection on the graph as a dashed line. Okay, so that's what I'm doing right now. And I'm going to say this is the line x equals 2. That's my line of reflection. You with me so far? Again, that's something to go back and look. If it was section 3.45 where we kind of talked about vertical and horizontal lines. So x equals 2 is a vertical line. Okay, what are we doing? We're going to reflect this triangle over that line. So here's how we're going to do this. I feel like this is one of those ones that sometimes get confusing, but it's a counting situation. So like right now, when I look at point A, I see it's 1 unit to the left of this pink line. So when I reflect A over this line, where does it have to end up? It has to end up 1 unit to the right of the pink line. So that's what I mean by counting. Like, count until you get to the line 1. Oh, I got to the pink line. And now I got to count one more. I got to count that same amount and end up on the other side. So here's point, what we're going to call A prime right there. Whoops, I'll put my little prime on there. Okay, let's do it with B. B starts 1 unit to the right of this line. So when I reflect it over this pink line, we got to end up 1 unit to the left. That's going to be my B prime. And then we'll do the same thing with C. Count from C to the pink line. So let's count. 1, 2, 3 units to the right. So we better finish up 1, 2, 3 units to the left. That's where I'm going to put my point C prime. And there, as long as I can see my points, there's my reflected triangle. Okay, A prime, B prime, C prime. Okay, so we've graphed the pre-image and the image. The last part here would be the documentation part of it, where we show what are the coordinates of these new points, right? That's what the box is for. That's what we did in the previous lesson, is what are the coordinates of the new point. So this is an example of where we'll kind of, what I would say, retroactively go back through and say, all right, the graph is done. What are the coordinates of these new points? And that's just us pulling them off the graph now. So at point A ended up at where? 1, 2, 3, 1, 2. So at the point 3, 2 was the point A prime. Where's B prime? It's right here. It's at the point 1, 0. And then C prime ended up at negative 1, 1, 2, 3. Negative 1, 3. All right. I think that's pretty good. Both graphs made, everything's labeled, A prime, B prime, C prime. I've got the new coordinates. Let's try one more like that, accounting style. I call these both example one. It's like 1A and 1B. So again, if you're working at home or you're working out of your notebook instead of what we would be doing in class, I'll give you a second here, pause it, get it set up. If you got graph paper, I'm going to slide my, where do we go? It's the same triangle, I believe. And we're reflecting over a different line. Okay. All right, here we go. Let's go ahead. I'm going to start kind of where we started last time and put my triangle on the graph. 1, 2 is point A. C is 1, 2, 3, 0. I'm sorry, B is 3, 0. And then C is 1, 2, 3, 4, 5. 1, 2, 3. So there's A, B, and C. Give it the old connect the dots treatment. Awesome. Graph the pre-image. And now where are we reflecting? We are going to reflect in or over the line M. This is just kind of the name of the line M, but it has the equation y equals 3. Okay, we just got done talking about if anything x equals is a vertical line, anything y equals is going to be a horizontal line. Okay, and it's going to have all the y coordinates be equal to 3, like 0, 3, 1, 3, 2, 3. So we're talking about, I'll use that same pink color. This right here is the line of reflection, which has the equation y equals 3. Okay. All right, here we go. Same style, same process. Let's use a different color. Let's use red this time. How far are each one of these points away from the line? So point A is right here. It's 1 below the pink line. If I reflect over the pink line, we end up 1 unit above the pink line. So there's my A prime. Let's do B. B is 1, 2, 3 units below the line. Therefore, I have to end up 1, 2, 3 units above my line of reflection. Now, C is kind of unique. I'm glad this came up here. What happens when point C, or any point, is exactly on the line of reflection? Well, I don't think we have to change anything. How many units below the line is it? It's not. It's on the line. So I'm not going to travel anywhere. So C prime, or any point that's on the line of reflection, stays in exactly the same spot. Ooh, I don't know if I ever put my, let's see, 1, 2, 3, 1, 2, 3. I don't think I ever put my point there for B prime. Okay, so to finish that thought, just make sure that if you're on the line of reflection, you're going to stay on that line. All right, we'll give it the old connect the dots treatment. A prime, B prime, C prime. There was a nice symmetry going on here that you kind of get a visual confirmation. Picture folding the book or folding the sheet of paper like a book along this pink line. The red triangle should end up directly on top of the blue line, which I think we have here. And just like the last one, the last part of this is now to go back through and just document the coordinates of our 3 new points. Okay, so A prime, I'm just pulling them right off the graph. I have to go old school, just counting. What is the coordinates of A prime? 1, and then 1, 2, 3, 4. So that has the coordinates 1, 4. B is where? 1, 2, 3, and then 1, 2, 3, 4, 5, 6. You can definitely do some stuff with, this was 3 units below, now it's 3 units above. There's some stuff where you can kind of figure out where you double or cut in half type of things, but I think honestly it's just easier to count, like where did C prime end up? 1, 2, 3, 4, 5, 1, 2, 3. I should have known on that one. I didn't have to count. We said it didn't move, so it should have stayed 5, 3, and 5, 3. Uh-oh. Still recording? Oh, thank goodness. I was getting nervous there. All right. Okay, so there's two examples like that. Let's do one of these rule ones, okay, where it's very similar. It's a very similar process, although it's going to be reversed. We're actually going to fill in the table portion of this first. At least that's how I'm going to do it before I do the graph, okay? So let's take a look here at what I'm calling example 2. So it says the endpoints, I guess it should say that just the points of triangle ABC are -2, 2, 2, -1, and C, -5. Reflect the triangle in the line, or again, over the line, y equals -x. Graph the triangle and its image using proper notation. Okay, so in order for me to do this, I need to go back to my rule list and jot down at least what is the rule for y equals -x, right? I said I don't have it memorized. So I come back here, I find the y equals -x rule. And what does it say? It says basically turn the point AB. So this is what I'm going to write down. I'm going to say turn the point AB, and I'm going to write it kind of like a rule like we were doing the other day for transformations. AB becomes the point what? It becomes the point, am I looking at the right one? Okay. Opposite of B, comma, opposite of A. All right, so where are we at? Opposite of B, opposite of A. So I think it's helpful just to transfer the rule right here directly to my, just so I can kind of see what's going on here. And again, the interpretation is pick up this point, pick up the original X coordinate, slide it to the Y coordinate, and in that process, change the sign on it. If it's negative, make it positive. If it's positive, make it negative. Okay, so let's do that for all three of these points right here. I'm going to take, let's start with point A. What's going to happen to it? It's going to turn into A prime. But what do we do? This 2, now this one's kind of tricky here. This -2, right, in that first position, gets picked up and it gets slid to the second position right here. But during that process, right, so from A to -A, or the opposite of A, I'm picking this up, I'm putting it in that second position, and as I move it, I'm going to change signs on it. So it turns from -2 into +2 right here. And I'm going to do the exact same thing, but just in reverse. From the B, I'm going to slide it forward so that this 2 that's in the back to begin with slides forward. It slides up to the front position. And in that process of sliding it, it goes from B to the opposite of B. So right now it's 2, but as I slide it forward, it's going to become -2. All right, and we're going to continue on for each one of my points and finish up that process. So after you do it once or twice, you start to figure out like, okay, this 2 gets slid to the back and it becomes negative in this case. It goes from +2 to -2. As this -1 gets slid forward, it goes from -1 and then it becomes +1. Okay, one more here. Let's pick up this -5. Whoops, let's get it at least set up. C prime is going to be, pick up the -5. This one, it really doesn't matter because they're both of the same number, but obviously let's do it the right way. This -5 gets slid to the back and I change the sign, which makes it positive. And the -5 is going to slide up front and we're going to change the sign on it to +5. Okay. All right. So we've got our new coordinates. Let's plot the original. I mean, that's the work is done there for the most part, right? We have the original, the pre-image, the image. The only thing that we have to add, obviously besides the points to the graph, is unless it's the X or the Y axis, because those are kind of hard to see, I do want to put this line on the graph. Okay, the line Y equals -X. So that was going back to what we had talked about. It's this 45-degree dashed line that passes through the origin. How am I going to remember where that is? I'd say the easiest thing to do is kind of how I did it. Just start the origin and go down 1 over 1, down 1 over 1, down 1 over 1. There's my line, Y equals -X. Okay, or again, the opposite of X. All right. But again, besides plotting my points, I'm done with this problem, right? So let's put them on there. Let's label everything. I've got my prime notation all laid out. Where's -2? 2, there's my A. B is going to be, so I'm graphing this one first, if you weren't, because I know those are the same points. I'm going to graph the pre-image. Let's see, I've got 2, 1, 2, -1. There's B. And then C has the coordinates -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -5, -5, which is over here. We'll give it the old connect the dots treatment. Okay, wasn't my best connect the dots treatment, but it's all right. Let's do our reflection. I already know the coordinates. And again, we saw this not too long ago, that this A prime, because it was on the line of reflection, that's why it didn't go anywhere. That's why it stayed -2, 2, -2, 2. So that holds true with what we talked about a little bit ago. What are my two new coordinates here? B prime is 1, -1, 2. It's kind of hard to see it here, but we're down here, B prime. And then C prime ends up completely opposite corner here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 up here at 5, 5. So that's C prime. Give it the old, maybe better connect the dot treatment. And I think we're good. Again, my drawing's a little sloppy there. If you want to use a straight edge to make it look nice and neat, you're obviously welcome to do that. That's not going to be a negative thing to do. But I think we hit it all. We graphed the triangle, its image. We use the proper notation, prime notation all over the place. Yeah, and obviously we could do that with any one of the other 4 or any of the other 3 special lines, okay? All right, here we go. Last part of the notes. Look at that. Not one of our longer ones. Reflection. We can also do reflections using matrices. Okay, so set up a section in your notebook that it just says method number 2 using matrices. Matrices can be used to reflect over these same lines. It says how do we do that? Basically, is going to be multiply the pre-image matrix by the appropriate reflection matrix. So definitely add these to your notes. This will also be given to you. You don't have to memorize these. It's a bunch of zeros and ones and negative ones. It's those same 4 lines, x-axis, y-axis, y equals x, and y equals -x. It's just a different method as to how to do those reflections, okay? So obviously, again, pause, add those to your notes. Let's set up and show how we do that, okay? That's kind of the last part of this. All right, here we go. We've got... looks kind of similar. I'm giving you some headings here as far as to how to set all this stuff up. It says triangle ABC has the vertices A, -2, da, 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 da. You can read them there. It says write the ordered pairs in a pre-image matrix. That's going to go right here. We're going to use a matrix to reflect a triangle over the x-axis, okay? And then write the image matrix. So that's going to go right here. Graph and label both the pre-image and image, okay? So let's do this. I am going to come back to... I'm going to come back to my slide here and do the reflection matrix, which is right here. Which one are we doing? We are doing, I already forgot, the x-axis. So I'm going to come back and grab my x-axis one, which is 1, 0, 0, -1. I'm going to write that right away. 1, 0, 0, -1. That goes here. Why does it go here? Because that is my reflection matrix, okay? That's the one, that's the appropriate one for the x-axis, okay? Okay, next thing we have to write. Let's turn our ordered pairs that are right up here, let's turn those into the pre-image matrix. Remember, labeling, this goes back to the previous lesson, so if you're like, I don't know what's going on right now, go back and watch lesson 4.1 video notes. This is how you turn ordered pairs into a matrix. A has the coordinates -2, -2. B has the coordinates -3, 2. And C has the coordinates 1, 4. Okay, so that's my pre-image matrix. All that stuff is just kind of stock setup. The one difference between this and a translation matrix is we usually write this first, the pre-image matrix, and then the translation matrix second. You'll see why in a second why we like to write this one first. Basically, the reason is we won't be able to do the multiplication unless I write it like this. Okay? So anyways, let's do this. This is going back to now tying into another lesson, lesson 4.0. How do I do this matrix multiplication? This is a good review for us. Remember how this works. I take this top row and I turn it up right. I was using the phrase turn it up. That gets lined up with this. Actually, I guess before I get too far ahead of myself, if I'm doing this technically the way we did in class, What do I got to write? I should write out my dimensions here. This is 2 by 2. This is a 2 by 3. And we can do the multiplication because these twos line up. It's going to set us up for a 2 by 3 image matrix. I'm going to really try my best to squeeze it in here without getting too far into the graph. It's going to be a 2 row by 3 column matrix. And if I'm also kind of just presetting all this stuff up, I know I'm writing over the top. That's where I'm going to come up with my A prime, B prime, and C prime. Okay, so I got a little bit ahead of myself. I was going to do the multiplication. Let's turn it up now. Okay, I kind of like saying that. This top row, the 1 0, remember, gets turned up like this, and then I'm going to work it down these 3 columns with multiplication and addition. Okay, and that's going to fill in my top row of this new matrix. Okay, so I'm going to multiply that by -2, -2, right? I do the multiplication. 1 times -2 is -2. 0 times -2 is 0. I add those up. Oh, can I squeeze it in here without screwing this up? I get -2. Now you're going to see here, there's kind of little hacks you can do without having to write out every single multiplication. Let's do a couple here and you'll kind of see what's happening. So I did that the way we did in class. My 1 0 was still turned up. 1 0. I'm going to now multiply it by this next column, which is -3 2. -3 2. I do my multiplication. 1 times -3 is -3. 0 times 2 is 0. And I add those together, I get -3. What's going on here? What's happening to my top row? Look at this. -2, -2, -3, -3. If you're going to guess, what's my last number going to be here in my top row of my new matrix? Probably a 1. Let's see here. My 1 0 is still turned up. I'm multiplying it by this 1 and this 4. So times 1 times 4. 1 times 1 is 1. 0 times 4 is 0. I add those together, I get 1. What's the point here? What's going on? That's weird. It has to do with these being 1s and 0s. That's why these are set up like they are. That basically, if you go back to our rule of reflecting over the x-axis, what did it say in the rules? It says your x coordinate, look at this, the A stays A. So that jives with what we're doing here. My x coordinates aren't changing. -2, -3, 1, -2, -3, 1. Now what's going to happen here the second time around? I think I'm just going to clear this. So if you're doing your work, obviously you can rewind and get all that stuff. I need to do another round of that multiplication by turning this bottom row up. So if I turn up the 0 and the -1 and work it down, what's going to happen here? You can probably, like I said, you can probably see what's going to happen. I'm going to multiply that by that -2. I'm going to multiply it by the other -2. What do I get? 0 and +2. When I add those together, what do I get? 2. Okay. Repeat the process. 0, -1 is still turned up. Now I'm multiplying by this next column here, which is my point B. So times -3 times 2. Whoops, I didn't mean to do that. We get 0. We get 2. Whoops, I'm sorry, -2. I gotta slow down. And then I add these together, I get -2. One more round of my 0, -1 turned up. I'm going to multiply it by this 1 and this 4. So this 1 and this 4, I'm going to get a 0, and I'm going to get a -4. Now again, what just happened? This -2 became positive. This 2 became negative. This 4 became negative. Is that a coincidence? No, going back to my rule, what did we think was going to happen? The B, the second, the Y coordinate, is going to switch to the opposite of B. And that just happened when we did that matrix multiplication right there. So, yeah, we did end up essentially applying the rule, but obviously, technically, we were using the matrix to do it. Okay, so that's what I kind of meant. There's like a little bit of a hack there that you can always double check this with your rule to make sure that did this actually happen? Did I do it the right way? Did the signs change like they were supposed to? Again, sometimes these get flip-flopped if it was like a y equals x or x equals y equals negative x situation. So yeah. Let's see. Going back through, write the ordered pairs as a pre-image matrix, done. Use a matrix to reflect over the x-axis, done. Write the image matrix, done. The last part is just going back and through and putting these both on the graph. So let's take a look here. I'll use this purple again to get my ABC graph. -2 is right here. -3, 1, 2, 3, 1, 2 is up here. And then 1, 1, 2, 3, 4 is over there. So let's go A, B, and C. We'll give it the one last, actually not last, almost last. Connect the dot treatment. And here's where I'm looking now to see my my new triangle A prime, B prime, C prime. So let's see, we're gonna go -2, -2, +2. So up here, this is my A prime. B is gonna be -1, 2, 3, but then -2. There's my B prime. And then C prime is 1, 1, 2, 3, 4 down here. C prime. Give it the old connect the dot. Yeah, I think again we've got that symmetry going on there. I get questions all the time. Mr. Crow, can't we just count? Can't we just count? Hey, this C, it's 1, 2, 3, 4 above the line. Can I end up 1, 2, 3, 4 below the line? Absolutely. Like I'm not saying I can't control how you make the graph of this, but if I'm specifically saying write a reflection matrix, pre-image, and image matrix, this is kind of your documentation part that should be there as well. So the graphs, again, I'm not going to know if you use the rule or counting or a matrix to actually make the graph. I'm not saying like skip it or whatever, but at the same time, making and building the graphs, there's several options on doing that. Okay. Let's see. Do we hit it all? Everything's labeled prime notation. We've got everything labeled here, and I am out of slides. So that's awesome. We made it through. That's everything you're going to have to do from lesson 4.2. We reflected over given lines using a couple different methods. We used rules and we used matrices. So that's it. Let's finish it up. That's all I got for you. Lesson 4.2 in the books. I will see you in future lessons.